With that bit of information, about 90% of the test can be covered. Just that. Knowing what sign they are, what the pictures are, what the ratios are, all of it is pretty much on the test. And each question pretty much can be done in this fashion with a nice little picture of your own making. So if I'm going to graph sine and cosine, the first thing I'm going to do is when I do my initial angle, we've been calling it theta, we are now going to call it x. So instead of labeling our angles as theta, we can call it x. You can also call it t for certain things like if t is seconds. And once I do that, I want to graph this function, y equals sine of x. So how do you graph something that you have no clue how to graph?
You show us.
I show you eventually. Seriously, you don't remember?
We use a calculator.
And do what with it? Oh, graph it? That's a little cheating.
Yeah.
What if you had to do it by hand? You know, what if I wanted you to graph x to the fourth minus 2x squared plus 1? How would you graph this? You don't remember?
You do a chart.
You do a chart. You set up a little table, you choose values for x, plug it in, and generate y. Same thing here. Except this chart is going to go horizontally because there's so many numbers that are going to be on it. So we're going to put x up here, we're going to put sine of x down here. So the angle on the top and then the sine of that angle down below. Easiest angle to start off with.
0.
0. So this is 0 radians, not 0 degrees. 0 radians. And what's the sine of 0? How would I find it?
Calculator.
Nope.
Why not?
Picture.
So the calculator's not there.
If I go to the sine of 0, we would be at this coordinate over here, this coordinate. Which one of these coordinates, 1 or 0, is sine?
Isn't it the x?
Alphabetical. X, y,
Oh, so 0.
cosine, sine. So sine of 0 is 0 because it's the second coordinate. So our first point on our sine graph will be the origin. Next angle up I can find is pi over 6. What's pi over 6 equal to?
30 degrees.
30 degrees. So you come down to this picture and you find the sine of 30. What's the sine of 30? Well, it's some old hippie. So opposite over hypotenuse. From 30, opposite is
1.
hypotenuse is.
2.
So sine of 30 is a half. So we get the coordinate, pi over 6, 1/2. On a piece of graph paper. I'll show you how to plot this later. Next angle we can find is, next biggest one is 45, pi over 4. So 0, 30, 45 so far. Which picture do I have to look at?
The second.
The second one over here. So the sine of 45 is still going to be opposite over hypotenuse. So it's 1 over square root of 2. But if you rationalize it, it's square root of 2 over 2. Either one works perfectly fine, but the book will write square root of 2 over 2. All right, what's the next angle up? 30 pi over 3, which is 60. So we go back to the 30-60 90 triangle. Now remember, you're looking at this top angle up here. So when I do sine of 60, opposite now is square root of 3, hypotenuse is 2. So this becomes square root of 3 over 2. What's the next angle up I can find? I got 0, 30, 45, 60,
90.
90, which is pi over 2. So how do I find the sine of pi over 2? What picture do I have to look at? Can I use the triangles?
The top one.
The top one, unit circle. Pi over 2 is up here,
So it's 1.
and sine is the second coordinate, so it's just 1. 0, 1, we pick the 1. Now, here comes the fun part. What's the next angle I can find after 90?
It's
180.
180 would be way too far.
You can find
Well, the pattern goes like this. It goes 0, 30, 45, 60, that's 90.
120.
120 would be next. 135, I think it would be, and then 150 would be the next one. But in pi terms, this one actually becomes 2 pi over 3. And the next angle becomes 3 pi over 4. And the next one becomes 5 pi over 6. So you'll notice that the denominators go 6, 4, 3, 2, and then it starts counting the other way, 3, 4, 6. So that pattern is always going to be going on as we move from one quadrant to the next. These long lines. All right, what's the sine of 2 pi over 3? Now I've got to be careful. In the second quadrant, the sign is positive, and when we reference the 2 pi over 3, what does it become? Remember, reference, that's what we did last class. If you have a pi over 3 that cuts the top into 3 pieces and you back off 1, so what's the reference angle? Backing off 1. So it would be...
Are you waiting for one word?
yes, I'm waiting for the answer.
Negative?
If your angle is 2 pi over 3, it's here. The reference angle is what's left.
Oh, so that would be 60.
60 pi over 3. If you go 2 pi over 3 and back off 1, what you backed off was pi over 3. So we go back to 60 degrees. What's the sine of 60? Well, square root of 3 over 2, and the emphasis is it's positive in the second quadrant. So we get square root of 3 over 2. Take a guess what the answer is for 3 pi over 4.
Square root of 2 over 2.
Square root of 2 over 2. It's going to be the exact same answer as pi over 4. 5 pi over 6.
1/2.
1/2, because it's in the second quadrant, is still positive, so it gets a half. And then finally, I'll put pi up here.
Is it just 0?
Pi is 0 because then you're way over here on the unit circle. The second coordinate is 0 because the coordinates are cosine and sine. So you get 0. That's half the curve. Well, half of something at least.
Half of a circle.
Half of a circle. Well, as we go around the unit circle, yeah, it's half of a circle, but the graph isn't a circle, which is interesting in itself. So sine of x here, I'm going to put pi just to start off with. We know it's 0. So it kind of corresponds with the 0 above it. What would be the next angle? Well, it went 0, 6, 4, 3, 2, 3, 4, 6.
4.
It would probably be 6. So pi over 6.
Would probably be 6, or it is 6.
You tell me.
It is.
If you're at 180, what would be the next angle you could find? 30 more degrees.
So 6.
So it would be, how many pi's over 6?
I'm going to go with
6 in the top,
7 pi?
1 more. So
Yeah.
this would be 7 pi over 6. The next angle would be a pi over 4.
would it be 8?
4 in the top,
5 pi over 4.
1 more. 5 pi over 4. If it's 8 pi over 4, that's actually 2 pi.
Yeah,
All right, what would be the next angle?
I do.
More than likely a 3.
Yes, 4 pi over 3.
4 pi over 3. 3 in the top, 1 more. Next angle?
3 pi over 2.
3 pi over 2. Next angle?
2 pi, whoa.
No, that's so quick. It went 6, 4, 3, 2, so now we start back with 3. So if it's 4 pi over 3 to get into the third quadrant, how much to get into the fourth? Because after you're by 3 pi over 2, you're in the fourth quadrant.
Yeah, 5
So
pi.
5.
So that'd be 5 pi over 3.
Ouch.
The next one would probably be a 4 on the bottom. How many would it be? It was
6.
5 here. 6 pi over 4 reduces to 3 pi over 2. So it can't be 6. 1 more.
7 pi.
7. So 7 pi over 4, because 8 pi over 4 would be a full rotation, 2 pi. And then the next one would have a 6 in the bottom. How many pi's over 6 get you into the fourth quadrant?
I'm going to say
6 on the top, 6 on the bottom, back off 1.
so 11.
11. 11 pi over 6, and then finally 2 pi. So that would be one full rotation of our unit circle and the coordinates that go with it. So what's going to go with 7 pi over 6 when I take the sine of 7 pi over 6? What's going to happen? Well, it's going to behave like the other pi's over 6. The answer is going to be 1/2.
That's going to be a negative.
But it's going to be a negative because in the last two quadrants, sine is negative. So this will be,
So is every answer in the bottom going to be negative?
uh-huh.
So it
Because
just goes back.
That's why I
It's negative.
try to line them up that way. So it's negative 1/2, negative square roots of 2 over 2, negative square roots of 3 over 2, negative 1, negative square roots of 3 over 2, negative square roots of 2 over 2, negative 1/2, and then finally back to 0. And you can check a couple of them, like 3 pi over 2 is this angle here at the bottom of the unit circle, and sine is equal to negative 1. So it kind of corresponds. All right, so the last step is, well, to graph it. Now to graph it, I'll try to be careful. It's going to take up a little space. It's going to be a little strange. What happens is with 30, 45, and 60, they get grouped together because they're 15 degrees off. But to the left and to the right is double the space. It's 30 degrees on the left and 30 degrees on the right. Do you understand what I'm saying? Probably not. So when we do our scale, we're going to have 0 here. 30 degrees in, we're going to have 30. But to get the 30 to 45 is only half that distance. So it'll only be like here, 45. And then half that distance, the beginning distance, to get to 60. But then we get that whole distance again to get to pi over 2, 90. So it's going to be 3 marks really close together, but with bigger gaps on both sides. So when I do this, I'm going to choose this to be 30 degrees. Then half that distance would be 45, 60. Then another 30 degrees, that would be pi over 2. So I'll put pi over 2 here. And then try to keep it. This would be pi. 1, 2, 3. This would be 3 pi over 2. 1, 2, 3. And way out here would be 2 pi. So it's a weird graph paper, but that's because the intervals are not equal. It goes 30, 15, 15, 30, 50, 30, 30, 15, 15, 30, 30, 15, 15. So it keeps that pattern kind of going. So the marks on the bottom is pi over 6, pi over 4, pi over 3. And then it turns around pi over 3, pi over 6, pi over 4. I'm sorry, pi over 3, pi over 4, pi over 6. So that's how the angles are going to go on this. What's the maximum value for this graph? What's the biggest value that's up here? How high is it going to go?
1.
1. That's the largest value you're going to get out of it. Which makes sense because the radius of our circle is 1. So the biggest x or y coordinate you could have is 1. What's the lowest it's going to go?
Negative 1.
Negative 1. So the maximum is, or I'm sorry, the minimum is negative 1, the maximum is positive 1. Then all we have to do, I don't think I've made that very equal, goes a little lower down here, is plot points. So what's the first point I plot?
0,
0,
0.
0. So we start at the origin. This first mark is pi over 6. So what's pi over 6 equal to? Well, a half. So half would be literally halfway to 1. Now I'm in trouble. I have to plot these points, but they're in radicals. So what the heck is square root of 2 over 2 equal to? I know what it's equal to, but can you find out for me? It's using a cell phone calculator. Oh. I can't
Is
read
that
from
scientific? Yes, I can use it.
Cutting edge.
cutting edge. What is the answer, though?
There we go.
Cutting edge yet can't get to the answer.
There we go.
Boy, about 0.7?
Yeah, 0.707.
707. The best I'm going to get is maybe 0.7 out of this thing. What about square root of 3 over 2? Remember it, it's like 0.86. How's that cell phone calculator doing?
It's working.
Did it get
I'm
0.86?
still trying to
Figure it out.
How's it doing? It's doing.
0.86. So this is really close to 0.9. Then you get 1. This is 0.9. This is 0.7. And then you get 0.5. So we basically know what the numbers are now. So at the next mark, which is pi over 4, we're going to go up to 0.7, which is right about here. When we get to the pi over 3, it's almost up to 1. When we get to the pi over 2, it's exactly equal to 1, right above it. And we get this curve to start off with. My points might not be perfect. All right, and then it just goes back down. 0.9, 0.7, 0.5, back to 0. So you get 0.9, 0.7, 0.5, and then back to 0. So that would be the second part of the curve, up to pi. Now this is as we rotate around the unit circle in this direction. That's that first half of the circle. So this is quadrant 1 on a unit circle. This is quadrant 2 on the unit circle.
Yeah, it's just
Yeah, it just kind of flips. But it's not a circle itself. It's actually a kind of a nice wave curve. Now, as we go down, what do you think is going to happen? Well, all those positive coordinates now become,
negative.
so we end up down here. And the shape of it is going to be exactly the same. Down here at -1, we'll have this curve. And it'll come back to 2 pi. So this is the graph of sine of x. It's kind of cool. Now, is that it? I mean, does it just stop like that and never goes anywhere
It keeps
else?
going, doesn't it?
Yeah, it keeps going because you can always keep rotating around the circle. So this thing will just keep going in this direction. It'll keep going in that direction forever and ever and ever. Yeah, it's just become literally a wave. Now, what are sine curves used for? Synthesizers, music.
Yeah.
Those little
Sound
booths you
waves.
can actually go in and sing and you sound like crap when you're in the booth, but then they can fix it and make you sound like a pro. They can actually fix your notes.
Auto-tune.
They do it with this sine curve. They'll fix
Yeah.
your notes with it. What else is sine good for? Vibrations of strings, like guitar strings.
Anything to do
Pluck
with
'em.
wavelength or
Anything that's sound related
Yeah.
actually has this. Light.
or light waves.
Yeah, light waves. Any wave
Electromagnetic.
whatsoever. Electromagnetic. All right, a couple little features about a sine wave. Feature number 1.
Those physical signs.
It starts repeating itself after this distance. When a graph starts repeating itself after a certain distance, it's called a period. And the period of a sine graph is 2 pi. And it doesn't matter which 2 pi you're talking about. I can take that blue line and shift it over a little bit, and it would still be considered a period because it'll start repeating from one point to another. But usually, most common period is 0 to 2 pi. All right, so that's a nice feature about sine. Now, do you have to go through all this process just to graph a sine curve?
No,
No, there's a quick way of doing it. The quick way,
I hope not.
oh, there's a super quick way. The quick way goes back to the unit circle, and you just travel around it on the 4 points. So when you graph a sine curve, it's just going to have 1, 2, 3, 4 points of interest along the x-axis. Pi over 2, pi, 3 pi over 2, 2 pi.
Yeah.
We know it's going to go up 1, and we know it's going to go
Down 1.
down 1, -1. And as you move around the unit circle, starting here,
Switch.
sine is equal to
Base.
0. At pi over 2, sine is equal to
1.
1. At 3 or pi, sine is equal to 0. At 3 pi over 2, sine is equal to -1. And then you're back to 0 or 2 pi, and you're back to 0. And then you get a nice little graph.
Why didn't you just do that to me?
Well, I have to show you the general shape of it first, and then we can shortcut the sucker.
But that is a general shape. It's the same thing.
Yeah, but I don't know. There's a little bit more subtlety going on. How it gets
You have to have
kind of
trees.
goes slow here at the top and then fast down the
You
side.
gotta cut down a tree before you can make lumber.
That too. So the pattern, another way of thinking about it,
You chop it down.
especially if we start moving these things around,
Yeah.
I call this line here the middle. This one up here is high, of course. And this one down here is, take a guess,
I don't know, it's low.
low. So the pattern for sine is middle, high, middle, low, middle. Middle, high, middle, low, middle. Starts in the middle, goes high, back to the middle, goes low, back to the middle. So you can kind of get an idea of where it starts and how it ends. All right. Now I can show you the shortcuts for all the rest of them. I only need to show you that one. From that one, we can generate all the rest. But notice, it always went back to those pictures. The unit circle, the trig, sentence, simultaneity, the special triangles. Once you have those, most of the stuff isn't too bad.
Yeah, so I'm just taking a stab in the dark.
Go for it.
Most trigonometry deals with the unit circle and all that.
I tried to... All right, what about y equals cosine of x? So if I want to graph y equals cosine of x, I can set it up as the quick version, the four corners of the unit circle. And since sine and cosine are both revolving around a unit circle, there is a relationship between them. Number one, they're cofunctions. But their graph generally should look the same, waveform. So we cut this into four pieces. This is pi over 2, pi, 3 pi over 2, 2 pi. We know its maximum is going to be 1, its minimum is going to be -1 because it's still stuck on a unit circle.
The cosine.
But where's the
Cosine just
cosine?
flip?
It's not just...
So is it
There's a lot of
cosine
manipulations you
low?
can do to a sine curve to force it to be a cosine curve. You can flip it, move it, shift it. There's a lot of different ways. But either way, when I take the cosine of 0,
Yeah.
It starts at 1.
remember this first coordinate is 1, 0, therefore cosine starts at 1,
So it's the same thing as that one, it's just the points.
where it starts. So if you can remember that sine starts in the middle and then goes high, and cosine starts at the top and goes middle next, don't ever skip over middle, then it's pretty easy. When we rotate up to this point, the coordinate is 0, 1, so cosine is equal to 0. When I move over to this point, the coordinate is -1, 0, so the cosine is -1 down here. At 3 pi over 2, the coordinate is 0, -1, but cosine's the first one, so it's back to 0. And then at 2 pi, we're back to the beginning, which is 1. So the pattern here is high, middle, low, middle, high. Now here's the problem with cosine. If I started with cosine, this almost looks like a V. But that's not what cosine is doing. It has the same shape as sine. So on this side, you kind of have to imagine that it's curving up to this point and then down. So you get something that looks like that. So that's a cosine function.
Hey.
Aren't these exciting? So how does it make different sounds?
Frequency.
Gotta change the frequency. The frequency is here, but I have to show you where it comes from. So before I can change the frequency, I can change a few other things. What should I do to it first?
Wavelength. Amplitude.
Oh, maybe I should do amplitude first. Yeah, let's do amplitude first.
Oh, phase. I don't want to go with a phase. No.
Amplitude. To make a sound louder or softer, we could just have to change the amplitude. So for instance, if I have y equals 3 sine of x, the 3 up front does only one thing. It takes every one of the y coordinates and multiplies it by 3, so it becomes 3 times as high. So where our normal sine function, 1, 2, 3, 4, 1 up, 1 down, the normal sine graph, where would it start? Oh, this is pi over 2, pi, 3 pi over 2, and 2 pi.
Start at 0.
And it starts at 0.
0,
It's
1,
gonna go
0,
up.
Then it goes up to 1, back to 0, down to -1,
Back to
back to 0. So this would be our normal squeaky sine graph.
So you just make it 3 times as big.
Make it 3 times as tall. Yeah, as in this
as tall and
direction.
as high and as deep.
High as in deep. It'll still keep the same x-axis. It just changes the y-axis. So here's -3. Here's +3. So it starts at 0, 0. Stretches itself up to +3, down to 0, down to -3, back to 0. So this is where sound gets a little bit louder. The period has changed. It's still 0 to 2 pi, but it's just gotten a lot.
It's the same
Taller.
frequency.
Same frequency, just different amplitude. So 3 times as loud. Well, my speaker sound. Okay, what about phase shift?
Yes, phase.
Oh, these are really good at describing Ferris wheels too. The ride itself. So as like you get across the top, it's kind of boring, but up the sides, you get the gravitational acceleration in the opposite direction. Both sides a little bit. Probably on the back side a little bit more than the front side. Though the front side's kind of scary because you're the
There's
cart.
nothing in front of you.
Yeah, there's nothing in front. So a phase shift allows you to take the Ferris wheel, which, you know, the unit circle usually starts over here on the positive x-axis, and you have to swing it down to the negative y-axis so you can get on the Ferris wheel. So that's considered a phase shift. So let's see. That would be something like y equals sine of x plus pi over 6. This would be considered a phase shift. And the way to kind of tackle it is to think of this as the angle theta. For a regular sine curve, theta usually goes for us 0 to 2 pi.
Yeah.
So you let theta equal 0, you let theta equal 2 pi, and you see what happens. Alright. So if I have theta is equal to 0, that means x plus pi over 6 is equal to 0. But then x is equal to negative pi over 6 when you solve for it. On the other one, you're going to get x plus pi over 6 plus 2 pi, equals to 2 pi. And therefore x is equal to negative pi over 6 plus 2 pi. So what happened to the graph? So instead of going 0 to 2 pi like it's supposed to, you are now going from where to where? From negative pi over 6, which is just to the left, to pi over 6 shy of 2 pi. So this would be negative pi over 6 plus 2 pi. Now the period itself, the distance between those, if you find the distance between these 2 points, the period is still 2 pi. The period is still 2 pi.
Yeah.
All you do is take both endpoints and shift them to the left 2 pi, or pi over 6 units. So that pi over 6 is considered a phase shift to the left. Notice on the inside it's opposite side. But don't let that throw you, because I don't even care about that. Generally what I want you to do is get used to doing this split, because it helps with one other piece. All right, so how would I graph that function? Well, it starts off almost exactly the same. It's still going to go 1 high and 1 low.
You just graph it like you normally would and shift it pi over 6 to the left.
Right, so I need my marking. So this one's pi over 6, negative pi over 6. What would be my next mark? And then it gets kind of...
Your next mark?
Yeah. So here's what you're going to do. You're going to set up a table. Your normal cuts are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are your normal cuts. What you need to do to each one of them is shift them. And we need to shift it by negative pi over 6. So what you do is you add negative pi over 6 to each one of them. So 0 minus pi over 6, of course, is negative pi over 6. That gives you your first one. What's pi over 2 minus pi over 6? Good Lord, he's going to do it on his calculator. What's the common denominator?
12.
Oh, better. That's 6 would be easier.
Oh, yeah.
What do I have to multiply 2 by?
3.
So it would be 3 pi over 6. So what's 3 pi over 6 minus 1 pi over 6?
Or just 2 pi over 6.
And it reduces to
Pi over 3.
So this becomes
Negative pi over 3. No, just
pi over 3. Pi over 2 is bigger. All right, what's pi minus pi over 6? Well, what's the common denominator?
6.
So it would be 6 pi over 6 minus 1 pi over 6.
Pi over 6.
That's 5 pi over 6. 3 pi over 2 minus pi over 6.
It's 8 pi over 6.
It would be 9 pi over 6 here minus 1 more, which is 8 pi over 6, better known as
4 pi over 3.
4 pi over 3. 2 pi minus pi over 6.
That would be 11 pi over 6. The final answer.
Yeah, this one's 12 minus the 1 over there is 11 pi over 6. So when I do my marks, this is negative pi over 6. Oops, wrong color. Pi over 3 is double pi over 6. So if I make this 1 unit, I have to go 2 to get to pi over 3. This length, whatever I make it, can't change. So wherever you put pi over 3 over here, keep that length exactly the same and just move it out. I'm not going to have enough room to run out of board. So if I keep it the same length, then this would be 5 pi over 6. And if I could do it one more time, I'm not sure if I can. Yeah, it's going to go, yeah, that's off. That would be 4 pi over 3, and so forth and so on. So where does this graph start? I should have done a cosine. Darn it. That's all right. Where's sine start?
0.
Here at the origin?
No, there's 0.
At the
Oh, that's 0.
negative pi over 6.
At negative pi over 6, at 0. All right, then what?
It doesn't go up to 1.
At pi over 3.
At pi over 3, you go up to 1.
It goes back to 0.
At 5 pi over 6, you go back to 0. At 4 pi over 3, you're down to negative 1.
Did it show up?
And then if we can get to it, 11 pi over 6, it would go back to 0.
0, yeah.
So your curve is shifted
Out of phase.
to the left just pi over 6. So it looks just like a sine curve, just move to the left. So that's not too bad. So we have amplitude, phase shift. What else can we do to this mess?
With frequency?
Well, it's not called frequency, period. You affect the period. Affecting the period affects the frequency.
Shrinking and lengthening the period.
Yeah, if you shrink the period, it increases the frequency. If you lengthen the period, it's opposite relationship. So,
Inversely,
What about frequency?
how about change in period? Squishing and I always think of it as an accordion. You know what accordions are? Weird musical instruments that people never want to hear, along with bagpipes. So if we're going to change the period, it would be something like, I never liked the sound of bagpipes. It's not like crying.
It takes skill to use.
Well, there's that one guy that does the AC/DC song with it, and that's just amazing.
Really?
Yeah, watch it on YouTube. It's pretty cool.
He did,
What is it called?
He did Thunderstruck.
Just Thunderstruck on bagpipes. On
There's
bagpipes.
also
I'm one with that.
There's
there's
another
also
band that does it with violin or the
bluegrass,
bluegrass. Yeah.
banjo, and bass.
I don't know why they keep picking on that song. I guess it's hard to play. All right, so cosine of 3x. So this 3 has something to do with changing the period. Where a number on the outside changes how tall the graph is going to be, the 3 on the inside is going to change length of the period. So the way I'm going to set it up is exactly the same way as I set up the phase shift. The normal thing starts at 0, the normal thing ends at 2 pi. So I'm going to call this theta, and theta generally runs for us between 0 and 2 pi. So I get 3x is equal to 0, and 3x is equal to 2 pi. So over here, x is still starting at 0. That hasn't moved because it wasn't shifted. The other one, though, tells us that we're going to end this graph that usually took 2 pi to finish off. We're going to end it in 2 pi over 3, a third of the length. So basically you take the whole graph and you shove it into a third of the length, and therefore the ups and downs get a little bit closer together. All right, so if I'm going to do this, I still need to cut it into these parts. And sine and cosine always starts with 0. If I need to end this in 2 pi over 3, I have to find these 4 equal pieces. So what's the quickest way to find 4 equal pieces out of a number? Divide it by 4 or multiply it by 1/4. Much easier to multiply this by 1/4. So the next thing you do is you take this number. By the way, this becomes the period. You take this number, you multiply it by 1/4, which is equal to pi over 6.
2 pi over 12, yeah, pi over 6.
Pi over 6. So our 4 equal cuts are going to be pi over 6. So this will be 1 pi over 6. The next one would be pi over 6, better known as 1 pi over 6. 2 pi over 6.
Yeah, 2 pi over 6.
Which is pi over 3. Dang it, I wrote pi over 6. Pi over 3.
Fail.
Next one would be 3 pi over 6, better known as pi over 2. The next one would be 4 pi over 6, which is better known as 2 pi over 3.
And there's your period.
And there's your cuts, yeah. So when you start graphing this thing, do it blue, you're still going to have 4 equal cuts. I'm going to put them rather close together. It's still going to go up 1, down -1. But now your cuts are going to be pi over 6, pi over 3, pi over 2, and 2 pi over 3. All right, if that's pi over 2, over here would be pi. I'll just need that one for reference. So if I was going to draw my original graph, this is cosine. Where does cosine normally start? At 1. So at 0, 1. Then it comes down normally at normal. I'm not graphing this graph yet. Normal cosine, pi over 2. So it'll come down at pi over 2. And then down at -1 at pi. So the beginning of a normal cosine graph would look like this, up to that point. What happens to the normal cosine graph is it's going to get squished. So if I do the same thing, it's going to start at 0, or 0, 1. At the first cut, it's going to hit the middle. So that first number, whatever it is, it's going to hit the middle. So high, middle, low, middle, high. So at pi over 3, it's going to go all the way down. At pi over 2, it's going to go back to middle. At 2 pi over 3, it's going to go. I hope it doesn't. And therefore, this graph is starting to look like this. It finishes one whole period before this one even finishes, well, a little bit over when it finishes half its graph. Not even half its graph. Half its graph is at pi.
Yep.
So it gets done before half of the graph is done. And you could fit 3 of the squished ones inside one of those green ones.
Because it was right there.
Yeah.
So that lets you know.
Mm-hmm.
So you can use that kind of as a reference too. You can pretty much cut the original into threes.
Right. So if this was 4, you'd have 4 graphs within 1. So you only have to finish it in 1/4 of the distance. If that number was in the bottom, like x over 3,
You would have to be 3 times as big, right?
so when would it start? 0. When would it end?
3 times as big.
Which would be
6 pi.
6 pi. So it would be really long and drawn out. Low frequency radios. What do they call them? Shortwave. Shortwave is high frequency. I always forget which one's which. AM. AM compared to FM.
Yeah.
AM has a very long, boring, and FM has megahertz, so it shoves them all together. All right, so let's do them all together. What time is that? You're all awake, right?
No.
No.
Jeez. Sorry.
It's not Monday. Come on, man.
It's not Monday, it's Wednesday.
It's Monday to me.
Every day is a Monday.
Every day except for Friday.
Every day is a Monday.
Left shark.
So, for example, let's graph something horrible. Y equals -2 cosine of. I better not make this up, otherwise it'll be
Y equals atrocity.
1/3 of x.
I don't want to. No, I don't want an atrocity because I don't have all day today.
1/3 x plus pi over 6.
That's not a good one.
What?
That's not a good one.
That has like all these put together.
Y equals cosine.
You can't just make it up because sometimes the graph gets
Why'd
horrible.
you make it up?
Please don't. I've done that before. Really bad.
Yeah.
2x plus pi over 3. 2x plus pi over 3.
Did that once. Create the frequency.
Hopefully this one won't be too bad.
It's gonna be horrible.
Alright, so what we need to find, amp, period, any phase shift. What else might we want to find? That's about it. And then of course the table. The table is always the end of the, right before the graph. Alright, so do you know the amp just by looking at this?
Yeah.
What is it?
It's the pi over 3.
Nope.
Where's-
Is it the negative?
Nope. Closer though. It's 2. Now amplitude is literally just the distance from the middle line to the high line.
Yeah.
Literally, that's what an amplitude is. When you look at a wave on the ocean, you don't measure the height of the wave from the bottom of the crest to the top
Yeah.
of the crest.
And the lowest
It's still water to how high it actually went. So the amp is literally the absolute value of -2, better known as 2. So it goes too high and too low. The negative does something fun to the graph, but we'll talk about that later. How do I find the period and the phase shift?
Period's a 2x.
It's not equal to 2x though, it's related to the 2. So here's the trick. You take this whole thing, and you'll notice that this first one really doesn't give me a lot of information. So I'm not going to use it. I'm going to use the second one. And you take the whole thing and you say 2x plus pi over 3, and you set it equal to the period. That gives us actually both pieces of information. It'll give us the translation, and it'll give us the period.
So you solve for x and that's your period.
Now, when you solve for x, don't combine like terms. It's probably the only time I'll ever say that. Don't combine like terms. So the first thing to solve for x is move the pi over 3 over. And I always put it first, but it doesn't have to be. Whatever you do, don't change the order of how you do it, because the first one is going to be one part of the puzzle, the second one is the second part of the puzzle. All right, then what? So when you divide by 2, what's pi over 3 divided by 2?
Is it pi over 6?
Are you guessing?
Yes.
Well, you're right.
Awesome.
But the better way of thinking about it is, instead of dividing by 2, multiply by a half. So it would be pi over 6. So this will be negative pi over 6
Don't divide.
plus
4 pi? No. Divide.
pi. You're divided by 2.
Bleh.
Pi.
Who's dividing? Look.
Guessing is good up to a point.
Yeah.
Yeah.
Guessing
This one,
Guessing will get you so far.
that you just moved over by itself and then divided into it, this will always be your phase. And this one will always turn into your period. In other words, the 2 pi, whatever you do to that 2 pi, that's going to be your period. All right, so my phase shift is negative pi over 6. My period is now half
So
the
you
distance.
define the period and the phase at the same time.
In that one formula. Because that's how I did it for both of them. I set up the phase shift this way. And nothing happened to the period, but the phase shift showed up in front of it.
Right.
But when I divide by the 2, the period gets changed and the phase shift, which is kind of cool.
So what if you didn't divide by the 2?
Then you wouldn't be able to figure out anything.
That's why you don't combine like terms.
And that's why you don't combine like terms, because you want to see the translation and the period
Yeah.
separately. Okay. Now, once you get to that point, you concentrate on the period and you cut it into
Is it 4?
4 pieces, just like a unit circle.
Another guess.
When you draw your unit circle, how many pieces is it cut into? 4, and that's what you want. So, off to the side here, take your period and go pi times a 4th is better known as pi over 4. So these become your equal cuts. So when we set up
They're
our,
only going to shift over power 4. Like it's going to start at negative power 6 and it's just going to move over power 4. All the way until it gets to pi.
all the way until it gets to, well, it's been shifted, so it won't ever get to pi. Well, yeah, it won't ever get to pi. Might actually go beyond if it was positive. So our normal cuts usually start with 0 and then goes pi over 2, pi, 3 pi over 2, 2 pi. But our 4 equal cuts are now pi over 4. So when we crawl through this, it's going to be 1 pi over 4. This one would be 2 pi over 4, which would be pi over 2. This one will be 3 pi over 4. Can't reduce that one. This will be 4 pi over 4, better known as pi. This number has to match what you put in for the period. Has to match. If it doesn't, you did something wrong. From those, I need to take away pi over 6. So I got to subtract pi over 6 from each one of them because that's my phase shift. So I'm going to shift it to the left, pi over 6. So this will be negative pi over 6. The next one will be,
Isn't this going to define the common denominator?
which is,
It's going to be the 12.
and this becomes what kind of pi over 12?
It's 3 pi over
3 pi over 12 minus,
12. 2 pi over
better known as
4. Power.
pi over 12.
I don't remember what I said when the first answer was.
3, 2.
I was like, wait,
Pi over 2 and minus pi over 6. What's the common denominator?
6.
6. So I multiply him by 3, so it becomes 3 pi over 6 minus 1 pi over 6, which is 2 pi over 6, better known as plain old pi over 3. 3 pi over 4 and pi over 6 have a common denominator of 12 again. Multiply by 3, this becomes 9 minus
2 is going to be
2.
7 pi over 12.
This will be 7 pi over 12. This would be 9 pi over 12 minus 2 pi over 12 over there. Yeah, you forgot to get a common denominator.
Yeah, I got it for the first one. That was it.
Now pi and pi over 6 have a common denominator of 6. This is 6 pi over 6 minus 1 pi over 6, better known as 5 pi over 6. So that gives us our x-axis. The amp gives us pretty much our y-axis. So what we're left with is, what the heck does this do?
The negative.
The negative.
It flips it.
Flips it over. So where cosine usually starts high, now it's going to start low and go backwards.
So
Alright.
it's just going to be an upside down V.
And we've also got a phase shift.
We'll get it all in there.
Yeah.
There. All right, so the phase shift is negative pi over 6. I'll put it here. Hopefully this one fits. Pi over 12 will more than likely go someplace like here. And then from that point on, once I fix that first length, I want to copy it over so I have 4 chunks. So let's see, about that long. It's real easy to screw up from here to here because that line going down the middle, it throws your vision off, so rulers come in handy. And then one more. And then one more. 1, 2, 3, 4, 5. That's enough. So pi over 12, pi over 3, 7 pi over 12, 5 pi over 6. And it goes,
But that whole distance together is pi, right?
this whole distance from negative pi over 6 to positive 5 pi over 6.
That's pi.
Remember how to find distance, subtract?
And
So it's this one minus negative pi over 6, which is 6 pi over 6.
So it's
Yeah, 6 pi over 6.
So it's
So how high, how low?
it's gonna go high 2, low 2.
High 2, low 2. So here's 1, here's 2, here's negative 1, here's negative 2. And then I can plot my points.
It starts off at negative 0, right?
It starts, it's a cosine graph, so it either starts high or low. Because of the negative, it starts low up below the phase shift. So cosine is starting way down there at negative pi over 6, negative 2.
And it's gonna go to 0, right?
0 where?
At pi over 12.
So it hits the middle line at pi over 12. Then at pi over 3 it goes
up to 2.
up to 2.
So it's
At 7 pi over 12 it goes back to
Middle.
middle. And then at 5 pi over 6 it goes
negative 2.
low at negative 2. And remember with cosine you have to kind of start it off early to get it to look nice. And end it late. So that would be a little bit more than one period of that curve.